Okay guys, so we're going to start Unit 1 today. Lesson 1.1 in your Cornell notes is going to be the distributive property. In your notebooks, I would like you to please make sure that you skip a page. So from where we took our last set of notes last week, leave one page blank because we're going to put a vocabulary page there when I get back. But you'll have the sheet now to add vocabulary, and we'll glue it in when I get back. And so we're going to start the 1.1 notes on the next page. So from the 0.4 notes that we took last week, leave one page blank, and then start your Cornell notes for 1.1 on the next page. So your essential question for 1.1 is, how do you use the distributive property to simplify an expression? You might need to pause the video every now and then to catch up because I'm not going to pause. So if you need to pause the video, just make sure you tell your sub and they will make sure that the video gets paused so you guys can catch up. So to start the distributive property, let's look at an example of this in terms of geometry. So if I have a rectangle, and it's kind of hard to see, so I'll write it a little bit bigger. On the rectangle, the length is 8 and the width is an expression x plus 5. If I wanted to find the area of that entire rectangle, we multiply length times width, which is 8 times x plus 5. So if we can multiply 8 times x plus 5, we can figure out the area. Another way that we can look at this, if I take the exact same rectangle with the length of 8 and I split it into two sections. One section is x and the other section is 5. So essentially this width is x and this one is 5. It's the same as x plus 5. We just broke it into 2. We can find the area of both of those individual pieces. So the area of this part of the rectangle would be 8 times x, or 8x. The length here is also 8, so the area of this part of the rectangle would be 8 times 5. And then we could just add those two pieces together. Essentially, this is the distributive property in terms of geometry. So you guys are going to add this to your vocabulary page. So on your vocabulary page that you got, there are 3 boxes, one for the vocabulary term, one for the definition, and then we're going to put an example. So that's our first term, is going to be the distributive property, and then we're going to practice a little bit. So the distributive property, the official definition, is multiplying a sum by multiplying each term individually and adding the products. In our example, I am using 3 times x plus 4, which is the same as multiplying 3 times x, so 3 times x, and then adding 3 times 4. So make sure you get those in your vocabulary page. And let's go back to our notes. So essentially that's what makes the distributive property work, is that we can look at it in terms of areas and then multiply the two areas together. There are many different ways that we can write the distributive property in terms of algebraic terms and then with some examples. So we're going to do that next. If I'm doing a standard distributive property, A times B plus C. We distribute the A, which is the same as multiplication, and that gives us A times B plus A times C. With numbers, the example that I give is 4 times 20 plus 6. We can distribute the 4, and that's the same as 4 times 20 plus 4 times 6. So that 4 gets multiplied into the sum individually. We can do the same thing if the number we are multiplying by is on the back of the parentheses. So we can also distribute from the back. A times B gives me B times A. And we can distribute the A in times C, so you get plus C times A. It's essentially the exact same thing. Everything gets multiplied by A. You can do the same thing with numbers. So I have 20 plus 6 times 4. So I distribute the 4 to the 20, and that gives me 20 times 4 plus, distribute the 4 to the 6, 6 times 4. And then of course, once you start simplifying, you will actually multiply and then add these together. We can also apply the distributive property with fractions. So if I have A divided by B, I can take that A and multiply it by the fraction 1 over B. So it's similar to the distributive property in that I would multiply A times the 1, and that's how I got the A over B. So in terms of numbers, if I have 7 over 10, I can pull out that 10, and that gives me 7 times 1 over 10. So we just pulled it out. Multiplying by 1 over 10 is the same as dividing by 10. So let's start doing some examples. Our first example, example 1 part A, is to simplify the expression 3 times x plus 8. Now the word simplify means to condense it as much as possible. So to make the expression as simple as possible. You can't solve because there's no equal sign, but to simplify means to put it all together. So I have 3 times x plus 8. So that indicates to me that I'm going to be multiplying 3 times these two numbers, so I'm going to use the distributive property. To remind myself that distributive is always multiplication, I draw arrows to the numbers that we're multiplying by, and then I write the multiplication out. So this is 3 times x plus 3 times 8. Now obviously this is not simplified as much as possible, so we can do a little bit more multiplying. 3 times x gives me 3x plus 3 times 8 gives me 40. I can't add 3x plus 40 because those aren't not what we call like terms, which we will get to in just a second. So you would leave that as your answer. Part B is to simplify the expression 5b minus 4 times negative 7. So since I am multiplying both of these by negative 7, I distribute the negative 7, and then I'll end up subtracting later. So this is going to give me 5b times negative 7 minus 4 times negative 7. (5b) times negative 7 is negative 35b minus 4 times negative 7 is negative 28. Now this is still not as simple as we want it to be because I have minus a negative. When I'm subtracting a negative, both of these change to positive because a negative times a negative is a positive. So that gives me negative 35b plus 28. That's as much as we can simplify because these are not like terms. Let's do a fraction. So example 2, we want to simplify 7x plus 2, all of that divided by 5. So what we're going to do is first we're going to rewrite this so that it is a distributive property of division. So I'm going to take out that divide by 5. So we can rewrite this whole thing as 1 over 5 times the top, 7x plus 2. Now I can distribute the 1/5. So I'm multiplying 7x times 1/5 and 2 times 1/5. I'm going to go to the right because I don't have enough space below. And that gives me 1/5 times 7x plus 1/5 times 2. And I can multiply these things. 1/5 times 7x, this is 7x over 1. So I can multiply the numerators, 1 times 7x, which is 7x, over 5 times 1, which is 5, plus, this is 2 over 1, so 1 times 2 gives me 2, and 5 times 1 gives me 5. These are not like terms, so we can leave our answer as is. Let's do one more example like this, and then we'll get on to talking about like terms. So example 3 says to simplify, that is a negative 2y minus 3x. So the negative is on the outside of the parentheses. When we have a negative on the outside of the parentheses, that's the same thing as saying negative 1 times 2y minus 3x. So I'm actually going to distribute the negative 1. So this becomes negative 1 times 2y minus negative 1. And I don't like a negative and a negative next to each other, so I'm going to put the negative 1 in parentheses times 3x. Negative 1 times 2y is negative 2y minus negative 1 times 3x is negative 3x. And then we have a negative times a negative, so that turns into a positive. So this simplifies to negative 2y plus 3x. So let's talk about terms and like terms and what I mean by those two things. So in your vocabulary page, we're going to add another vocabulary word called a term. A term is a number, a variable, or the product of a number and one or more variables. So a term in an equation or an expression is pretty much anything in between the operations, addition, subtraction, addition or subtraction. So an example of a term would be this entire thing, negative 6ab squared. It is made up of a coefficient, which is negative 6, and multiplied by two variables. One variable is a, and the other variable is b. b has an exponent attached to it. So negative 6ab squared is all one individual term. So when I say the word like terms are terms that have the same variables and exponents. So for example, 4a squared b and negative 2a squared b. These are considered like terms because they both have a squared b's attached to them. Another example of like terms could be negative 3x and 75x. These are both like terms because they both have x attached to it and nothing else. So the variables need to match as well as exponents attached to the variables. So everything that is attached to the coefficients needs to match. So back to our notes, the very last part of this is combining like terms. So to combine like terms, you simply add or subtract the coefficients of all the like terms. So we have one more example here. Part A, 8x squared plus 2x squared. What I like to do when I'm combining like terms is put circles, squares, underline all of the like terms. So right here I have an 8x squared and a 2x squared, a positive 2x squared. These are like terms because they both have x squared attached to them. So 8x squared plus 2x squared, I add the 8 and the 2 to get 10x squared. That's as far as I can go with it, so I'm done. Part B has a little bit more going on. So I have 5x minus 3 minus 3x plus 6 plus 4. So I'm going to put a box around all of the terms with x in it. So I have a 5x and a minus 3x. So let's combine those first. 5x minus 3x gives me 2x. And then I like to do any other variables we might have. So I have a plus 6y. And none of the other terms have y attached to them. So we're just going to rewrite it as plus 6y. Finally, we add the constants. So I have a -3 plus 4. -3 plus +4 gives me +1. So let's double check. Everything that's left over is a 2x, a 6y, and a +1. None of those are considered like terms, so you have simplified and you are done. So that's the notes for 1.1. You guys have homework from your actual textbook now, so you need to start bringing these to class. I know most of you probably did not today, which is okay. You can put it under the .cam. But in your homework log and on the board, it shows that you have homework from page 10. So you're going to go to page 10 in your textbook. And the problems start at 19 through 37. So you are going to start on problem 19 of your textbook and go all the way to 37, and then do 41 and 43 as well. Now on your homework, I have something very specific that I want you to do. So anytime your homework is from the textbook, you're going to be doing it on a separate sheet of paper, not from your notebook. And please do not start tearing sheets of paper out of your notebook either. So you are going to turn in homework to me just like normal, which is why it needs to be on a loose sheet of paper. On your homework, I would like you to please write your first and last name. Today's date, which is September 14th, 2015, and then the period. So this is period 3. I also would like you to please title your homework. So right on the title line, write homework 1.1, and then put the page and problem numbers. So page 10, number 19 through 37, 41, and 43. When you're doing your homework, put the number of the problem that you are doing, write out the problem, so on this one it is 3 times t minus 1. Please make sure that you are showing your work. So on distributive property, showing your work means writing each individual step. 3 times t minus 3 times 1. So that gives me 3t minus 3, and put a box around your answer. Then you can start the next problem, and you can go to the right and start making columns if you want. So for question 20 and then 21, or you can start going down. That's up to you, but you do need to have a box or a circle around your answer so that I can find it. So part of being a good mathematician is showing your work and showing it neatly so that other people can follow it. So this is how I would like you to label your homework. Be ready to turn this in tomorrow, and you guys may work on your homework for the rest of the period.